Hello everyone, welcome to the key to the review for this unit's test. I want to get started with question number 1. It says in the directions for questions number 1 through 4, find the solution to the quadratic inequality. We will represent our solution in set builder notation and graphically on a number line. We'll show all the work, including the factoring. Don't forget, whenever we factor, when a problem comes along, GCF it. So take a look at number 1. Number 1, it is set with 0 on the right side, which is exactly what we want. So the left side, we look for a GCF, and there is not one, so let's just jump right into the factoring. A times C is the key. 1 times negative 12 is negative 12. That's 1 and 12, 2 and 6, 3 and 4. The middle term is positive. So that means the big number is positive, so the small number must be negative. The pair that adds up to 4 is negative 2 and 6. So the factory, x minus 2, x plus 6, has to be less than 0. Set each one of the factors equal to 0. X minus 2 equals 0 tells us that x will be 2. X plus 6 equal to 0 tells us that x will be negative 6. So our number line will look like this. Negative 6, positive 2. The dots will stay open. We will not color them in because there is not an equal sign. It is just less than. And then we need to pick a point to see if it works in our function. So I would pick the point 0. 0 is located between negative 6 and 2. And if I were to plug it into the equation, I would get 0 squared plus 4 times 0 minus 12. That would mean negative 12 has to be less than 0. And it is. So I will color in between negative 6 and positive 2 because 0 worked. The set builder notation for this looks like x is between negative 6 and 2. Notice that there are no equal signs on those inequalities. Question number 2. We have a 0 already on the right side, which is really nice. So we will go ahead and GCF the left side. There is no GCF. But I can do 3 times negative 8 is negative 24. A times C is the key. That's 1 and 24, 2 and 12, 3 and 8, 4 and 6. Middle term is negative, so the big numbers are negative this time. And the pair that adds up to negative 10 are 2 and negative 12. I will use the airplane method now. 3x plus 2, 3x minus 12, and I will check to see if either of these two are divisible, and it looks like the right one is. It's divisible by 3. So my factor is 3x plus 2 times x minus 4. Set each one equal to 0. 3x plus 2 equals 0. Subtract 2 and divide by 3. X is negative 2/3. X minus 4 is equal to 0. Add 4 and x is 4. So my number line has 2 points, negative 2/3 and positive 4. They will get open dots because there is no equal sign in the problem. And I will again test the point 0. 0 falls between negative 2/3 and positive 4. So if I were to plug 0 in, I would get the first thing. 3 times 0 is 0. 10 times 0 is 0. So 0 minus 8 is negative 8. Negative 8 is less than 0. So again, I would color in between. The set builder notation would look like the following. X is between negative 2/3 and positive 4. I'll scroll back up to get question number 3. Question number 3. We have a 0 on the right side, which is good. Let's look for a GCF. There is one. It is 2n. I would be left with 3n plus 1 greater than or equal to 0. Let's set both of the factors equal to 0. 2n equals 0 means n would be 0. 3n plus 1 equals 0. Subtract 1, divide by 3. X is negative 1/3. So my number line, negative 1/3, 0. These dots get colored in this time. These dots are colored in because of the equal sign. Now I need to pick a point to test, and I can't choose 0 because 0 is one of the points already on the graph. So I'm going to pick a point greater than 0. I'm going to pick the point 1. If I were to plug 1 into the function, 6 times 1 plus 2 times 1 is 8. 8 is greater than or equal to 0. So since 1 is located over here, I will make my arrow go to the outside. It will be the same on both sides of the graph. The set builder notation for this one, because I am not coloring in between, this is actually an OR. So the left tail would be x is less than or equal to negative 1/3, or x is greater than or equal to 0. Question number 4. I have 0 on one side. I'll try a GCF. GCF is 2m squared minus 9. Hopefully you remember that m squared minus 9 is the difference of two perfect squares. It factors as the square root of m squared. One gets a plus, one gets a minus. The square root of 9 is 3. Set the factors equal to 0. M plus 3 equals 0 means m is negative 3. M minus 3 equals 0 means m is equal to positive 3. So my number line, negative 3 and positive 3. Open circles because of the lack of an equal sign. I'll test the point 0. 0 is in between negative 3 and 3. If I plug 0 in, I would get 2 times 0 minus 18, which is negative 18, and negative 18 is not bigger than 0. So I do not color in between them. My arrows would be on the outside. Set builder notation, this would be another OR. X is less than negative 3, or x is greater than positive 3. Questions 5, 6, and 7. The directions say complete the following information about each function. Try to find the y-intercept. To try to find the y-intercept, you'll either need to evaluate the function for x equals 0, or put the function in standard form to find the value of c. So let's look at number 5. The turning point, we can also call this the vertex. If I want to call this the vertex, that would be fine. When finding the vertex, and we pull the number away from the x, you see in parentheses x plus 6. When I take it away from the parentheses, don't forget to change its sign. Negative 6, the number on the outside, negative 1. The maximum or minimum, because the negative 2 is out in front, that tells me my parabola is upside down. So I will have a maximum value. I will have a maximum value at y equals -1. The axis of symmetry is always x equals the x value of the vertex. So x equals -6. And the y-intercept, I'm going to plug 0 into the function. -2 times 0 plus 6 squared minus 1. That's -2 times 36 minus 1. -72 minus 1 is -73. For number 6, again, the turning point can be just called the vertex if we like. And it's x minus 1, so change the sign to +1, and on the outside is a +2. The number in front of the squared quantity is +9, meaning my parabola opens up. So I have a minimum value. My vertex will be the bottom of the graph, and it will be found at y equals 2. The axis of symmetry is always x equals the x value of the vertex, so x equals 1. And the y-intercept, 9 times 0 minus 1 squared plus 2 is 9 times 1 plus 2. 9 plus 2 is 11. Please be careful when you are squaring a negative number that those answers are coming out positive. The calculators will sometimes trip you up on that. Number 7, the vertex. I see x minus 3, so my x value is +3, and on the outside is a +9. In front of the quantity is a negative sign, tells me that it opens down. So I have a maximum at y equals 9. The axis of symmetry is x equals 3, and the y-intercept, -0 minus 3 squared plus 9. That is negative. -3 squared is 9, plus 9 is 0. And that concludes page 1. Page 2 says for questions 8 through 10, find the value of c that will make the trinomial a perfect square. This is essentially just completing the square. We're going to complete the square each time. So if I want to think about this c as being my box, I would get x plus half of 4. Half of 4 is 2. So c is equal to 2 squared, which is 4. M squared minus 10m plus c. This would be m. Half of -10 is -5. So c equals -5 squared, which is 25. And a squared plus 9. Half of 9 is 9/2. So c equals 9/2 squared. This is the same thing as saying 9 squared over 2 squared. 9 squared is 81. 2 squared is 4. 81/4. For questions 11 and 12. Identify the turning point, or the vertex of the quadratic, by using the formula x equals the negative of b over 2a. Write your answer as an ordered pair. So the opposite of b, identifying a, b, and c. A is 1, it's in front of x squared. B is 4, it's in front of x. And c is -12. So x equals the opposite of b, so -4 over 2 times a. 2 times 1 is 2. Negative 4 divided by 2 is negative 2. To find the y value, I'll have to plug negative 2 into the equation. Negative 2 squared plus 4 times negative 2 minus 12. 4 minus 8 minus 12. This would be negative 16. So my point, the x value is negative 2, the y value is negative 16. Number 12. A is 2, B is negative 12, C is 7. X equals the opposite of B. The opposite of negative 12 is 12. Divided by 2 times A. 2 times 2 is 4. 12 divided by 4 is 3. Let's plug it in. 2 times 3 squared minus 12 times 3 plus 7. 3 squared is 9 times 2 is 18 minus 36 plus 7 is negative 11. So our point, x value is 3, y value is negative 11. For questions 13 to 16. Write the following equations in vertex form by completing the square. Then identify the turning point of the quadratic, show all work, leave fractions in simplest form. If we are going to complete the square, we must clear the constant first. So I will subtract 1 on both sides of 13. So y minus 1 equals x squared plus 4x. The right side, in order to be a perfect square, this will be x plus half of 4. Half of 4 is 2. 2 squared is what I'll add to both sides. 2 squared is 4. The left side is now y. Minus 1 plus 4 would be plus 3. And then solve for y. Subtract 3 on both sides, and y equals x plus 2, quantity squared minus 3. To find the vertex, x plus 2 tells me my x value is negative 2, and on the outside is a minus 3. So my vertex is negative 2, negative 3. Number 14, clear the constant first. Add 7. The right side. In order to be a perfect square, I have to take half of 2. Half of 2 is 1. Into the box is 1 squared. 1 squared is 1. Simplifying the right side, y plus 8. Solve for y, subtract 8 on both sides, x plus 1 quantity squared minus 8, the vertex. X plus 1 tells me my x value is negative 1 and negative 8. Question 15. Clear the constant. Add 2 to both sides. Y plus 2 equals 3x squared plus 12x. Now this problem's a little different than 13 and 14 because I have a 3 in front of the x squared, so I'm actually going to factor the 3 out. y plus 2 plus the box equals 3 times x squared plus 4x. Notice that the box is in the parentheses. The right side is 3x plus half of 4 is 2. So the box on the right will be 2 squared, which is 4. But because it's in the parentheses, I have to take my 4 and multiply it by the 3 that is out in front of those parentheses. And 3 times 4 is 12, gets added to the left side. 2 plus 12 is 14. Subtract 14 on both sides. Y equals 3. X plus 2 squared minus 14. The vertex is negative 2, negative 14. Question 16, very similar to 15. Clear the constant. Y minus 1. 2x squared plus 6x. I have a 2 in front of the x squared, so I will factor it out. The right side, 2. Half of 3 is 3 over 2. Into the box on the right is 3 over 2 squared, or 3 squared over 2 squared, which is 9 over 4. Don't forget to multiply your 9 over 4 by 2. That would give me 18 over 4, or 9 over 2. Combining my terms on the left. Y. Negative 1 plus 9 over 2 is 7 over 2. And then subtract to get y by itself, 2. X plus 3 halves squared minus 7 over 2. The vertex is negative 3 over 2, negative 7 over 2. That concludes page 2. Questions 17 through 19 are quadratic modeling questions. Answer each part carefully and show all work. Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is his height in feet. How long did it take for Jason to reach his maximum height? I can find this by finding the vertex of this parabola. The vertex of the parabola. To find the t value, and this is exactly what I want, I will use the opposite of b over 2a. A is negative 16, b is 16, and c is 480. So the opposite of b is negative 16 over 2 times a, which is negative 32. So the time for the vertex is 1/2 of a second. What is the highest point that Jason reached for part B? That will be the height at 1/2 of a second. So the height at 1/2 of a second is negative 16 times 1/2 squared plus 16 times 1/2 plus 480. Negative 16 times 1/2 squared. 1/2 squared is 1/4. And 1/4 of negative 16 is negative 4. plus half of 16 is 8, plus 480. Negative 4 plus 8 is 4, plus 480 is 484 feet. The next one wants to know, Jason hit the water after how many seconds? So when is Jason's height 0? So 0 equals negative 16t squared plus 16t plus 480. Well, I believe they are all divisible by negative 16. So if I were to divide by negative 16, I would get p squared minus t minus 30. And now I will factor the parentheses. 0 equals two numbers that multiply to give me negative 30 and add to give me negative 1 are negative 6 and positive 5. So t minus 6 and t plus 5. So my two possible times are 6 seconds and negative 5 seconds. Since my time cannot be negative, my only possible answer is 6 seconds. Question number 18 says a toy rocket is launched vertically upward from the ground level with an initial velocity of 128 feet per second. Then its height h after t seconds is given by the equation negative 16t squared plus 128t. So A is negative 16, B is 128, and C is 0. How long will it take the rocket to return to the ground? So when will the height be 0? I will factor out a GCF of negative 16t. And if I were to divide 128 by t, I believe it is 8. So negative 16t equals 0, so at time 0, and that's when the rocket takes off. And t minus 8 equals 0, so the time would be 8 seconds. Part B says, after how many seconds will the rocket be 112 feet above the ground? I'm going to need my calculator for this one. So let's bring up the calculator. My two equations are going to be negative 16x squared plus 128x. And my second one is going to be 112 feet above the ground. So let's think about the window. The rocket is shot at 0 seconds. And we said it takes 8 seconds for it to come back to the ground, so I'll make that an 8. My minimum height will be 0. And the maximum height, I know it has to be bigger than 112, so I'll go, I don't know, 180. And let's look at the graph. Well, you can see that we don't see the highest possible point, but I do need to just find out when this rocket will be 112. So I'm going to calculate these two intersections. So calculate the intersection. And I will find the left intersection first. And the left intersection is at time equals 1 second. You can see x equals 1. So time equals 1 second. The second one, if I go second, calculate, intersect. First curve, second curve. And now I need to guess again. And you can see that x equals 7. So my other time would be t equals 7 seconds. How long will it take for the model rocket to hit its maximum height? In order to do this, I'm going to have to find the vertex. So I will find the time of the vertex as the opposite of b over 2a. The opposite of b would be negative 128 divided by 2 times a, which is negative 32. And 128 divided by 32 is 4 seconds. And to find the rocket's maximum height, I will plug 4 seconds into the height equation. So the height after 4 seconds. It's negative 16 times 4 squared plus 128 times 4. Negative 16 times 4 squared is negative 256 plus 128 times 4 is 512. So 512 plus negative 256 is 256. So 256 feet. And that brings us to our last problem, question 19. Question 19 says, you're trying to dunk a basketball. As you guys know, I probably cannot dunk a basketball on a standard rim. But in order to dunk a basketball, we need to be able to jump 2.5 feet into the air to dunk the ball. The height that your feet are above the ground is given by a function, h of t equals negative 16t squared plus 12t. What is the maximum height your feet will be above the ground? So the maximum height, we need to find the vertex. So t equals the opposite of b over 2a. Well, a is negative 16, b is 12, and c is 0. The opposite of b would be negative 12. 2 times a would be negative 32. And negative 12 divided by negative 32 would be 3 over 8. So let's find the height at 3/8 of a second of our feet. So the height at 3/8 of a second, negative 16 times 3 over 8 squared plus 12 times 3 over 8. Here we go, negative 16 times 3 over 8 squared is negative 2.25 plus 12 times 3/8 is 4.5. And adding those together gives us a total height of 2.25 feet. So the question is, can we dunk the ball? The problem says, in order to dunk the ball, our feet have to be 2.5 feet off the ground. We can only get to 2.25, so no. We cannot dunk that basketball. Thank you for watching The Key, and good luck on your preparation.